Here's a really good application or use of logarithms. If you invest $600 in an account that pays 6% and it's compounded monthly, then how much is going to be in the account after 10 years? That one doesn't require logarithms. How long until the account doubles in value? You've got $1,200. That one requires logarithms. First, we need to be using compound interest formula. So the amount of money will be the principal, which is the amount invested here, $600, 1 plus the rate divided by n raised to the n times t. So the rate is given as 6%, but we need to use decimal form, 0.06. And then the n that shows up 2 places in the formula is how many times a year is interest paid. Well, because of this, n would be 12 months in a year. Interest is paid monthly. Okay, so we've got $600, 6% interest is paid monthly, and then the t is going to be the 10 years. So time for a calculator. 600, 1 plus 0.06 divided by 12, and then raised to the, if your calculator doesn't automatically go up like that and put both the 12 and the 10 in the exponent, if it does not, then you need to put parentheses around the 12 and the 10 to make sure that they are both in the exponent. So the $600 would grow to be $1,091, and we would need to round it to 64 cents. All right, there's part A. And then for part B, how long until it's doubled? So in other words, the $600 would turn into $1,200. So you need to put 1,200 right here for A. And then we don't know how many years it is, so this will be the letter T. So 1,200, if you start with 600 and put it in the bank at 6%, and then before we can use logarithms, we need to get rid of this 600 by dividing. So we would have 2, and that's really referring to the double when it's equal to 2 there. And all this stuff in parentheses, just leave it as 1 plus whatever. Don't try to simplify it because you'll have rounding error and then it'll throw off the answer. We'll just type it all in the calculator in a second. So next, take natural log of both sides. The reason for that, there's a rule for logarithms that says this exponent of 12t can be brought down in front of the natural log and you multiply. And then in order to solve for this t, we just divide by 12 and divide both sides by this logarithm. So we'll leave just the t. It'll make a big fraction with natural log of 2 gets divided by a 12, and the natural log of 1 plus 0.06 divided by 12. Now, there's a 12 and there's a natural log in the denominator, so I need to wrap parentheses around those so the calculator understands all of this is in the denominator. And then close the logarithm and close the fraction. And the time is 11.581 years. 0.581 years. So after about 11 and a half years, the $600 would grow into $1,200.